Today's notes are on the fundamental theorem of algebra. Some vocabulary that we want to make sure that we cover again are repeated zeros, which is a solution that appears more than once when a polynomial is solved. Complex conjugates, a pair of numbers in the form of a plus bi and a minus bi. So we have some examples here. You can also have it without the real number, so 3i and negative 3i. Remember that the number of zeros is equal to the degree of the polynomial. If a solution is repeated, it counts as two solutions. For example, number 1, it wants us to state the number of zeros for the following polynomial functions. So for example A, the highest exponent is 3. That makes it the degree of the polynomial. It also tells us how many zeros there will be. So example A has 3 zeros. Example B has 5 zeros because the highest exponent is a 5. The fundamental theorem of algebra says if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one root in the set of the complex numbers. Remember that a solution of 4 could be written as 4 plus 0i, making it a complex number. If there are complex zeros, they will always occur in complex conjugate pairs. So if a plus bi is a solution, then a minus bi must also be a solution. For example 2, they want us to, given the following zeros, state what other values must also be a 0. When it asks you this, you are looking for imaginary numbers. If I is a 0, its complex conjugate, negative I, must also be a 0. And for example B, if 2 plus 4i is a 0, its complex conjugate, 2 minus 4i, must be a 0. Let's look at this further on the next page. Writing a polynomial of least degree with integral coefficients and a leading coefficient of 1 given zeros. Your first step is going to be to include any complex conjugate in the list of zeros. Then, we will put the zeros back into their binomial form to create the complete factorization. Then we will multiply the polynomials together and put the polynomial into its function form by using f of x in front of your answer. So the first thing I need to do is check for any complex conjugates. For example A, we do not need to add any. Then we're going to put our zeros back into their binomial form. So if we know that x is equal to negative 1, if I want the x and the negative 1 to be on the same side, I would have to add 1 to both sides, which would leave me with x plus 1. Likewise, if I know that x is equal to 2, to move it to the same side as the x, I would have to subtract it to get x minus 2. Same thing for the 4. Subtract it from both sides to get x minus 4. And we also get x equals 0. These make up our binomial pairs. So I have x plus 1, x minus 2, x minus 4, and then when 0 is an answer, it gives you just an x, and I want to put that out front. You could also think about this as switching the signs in front of all of the numbers. Now we're going to multiply these together, and you can multiply them together in any order. So I'm going to choose to start with the last two binomials, and we're going to FOIL. So first, outer, inner, last, and I'm just going to recopy down the first two terms. This becomes x squared minus 4x minus 2x plus 8, which I'm going to simplify to be x squared minus 6x plus 8. Then I'm going to take x plus 1 and I'm going to distribute each term to the trinomial. So first distributing x to everything. Which will leave me with x cubed minus 6x squared plus 8x. Then I'm going to distribute 1 to everything, which will give me plus x squared minus 6x plus 8. Then I'm going to combine like terms inside the parenthesis to get x cubed minus 5x squared plus 2x plus 8. And finally, I need to distribute x to everything. We'll get x to the 4th minus 5x cubed plus 2x squared plus 8x. I want to make sure my answer is in standard form, so decreasing order by degree. We also want to make sure for this to be in function notation that we start off our answer with f of x equals. Again, it does not matter the order that you multiply your factors together in. We're going to look at example B and example C tomorrow in class, but feel free to try them beforehand.